Okay, so thank you all for attending this session, and please welcome Mike from SolidFire.
Y para la última presentación del día, vamos a hablar en español, okay? Just kidding. I'll do this in English. All right. So, how to develop API plugins in CloudStack. That little star thingy there saying that I specifically did this against version 4.5, but it should actually still apply up and pretty much without modification up until maybe the most recent stuff. I believe Rohit from ShapeBlue did some changes to the way we access roles and things like that. So some of the details might be slightly different around the 4.9 or 4.10 release, but pretty much everything should be unchanged for the most part. So who am I? I'm Mike Tutkowski. I work at SolidFire. I've been there working on the CloudStack code base for about 4 years now, 4 years toward the end of this month. I believe in the February timeframe, NetApp acquired SolidFire, so technically I work at NetApp SolidFire these days. SolidFire itself is based out of Boulder, Colorado, and we develop an all-flash array, which is what I've spent the majority of my time in the CloudStack community kind of enhancing the code around the storage area, sometimes around the hypervisor areas, to take advantage of features like quality of service, which weren't ever initially designed into the first few releases of CloudStack. So I've spent a lot of time not just writing the SolidFire plugins to actually talk to the SAN and make those kind of operations happen, but modifying the storage framework in CloudStack to support quality of service and other features like that. So I can probably skip the majority of these other bullet points for this particular presentation, since they don't really apply a whole lot to this idea of building API plugins. Those are more, I guess, relevant when I talk about how to build, specifically how to build storage plugins in CloudStack. But this is around building API plugins. And I guess you might wonder, first what that is and when you might actually want to go ahead and develop such a thing. So an API plugin in CloudStack is a plugin that kind of does what it sounds like. It actually allows you to take SolidFire's CloudStack's API, its standard API, and extend it with additional commands. So you can actually have multiple API plugins running inside of a single CloudStack environment, each of them providing their own set of extended API commands. You might want to do this in a few cases. So one where I had recently, and I guess a good example would be, a customer was using version 4.5 of Cloud Platform, and they could not change the code to add the extra features that they wanted from me. So what we decided to do was have me extend the CloudStack API with probably a dozen or so additional commands. And then those commands can be consumed from other clients, including a GUI plugin that I wrote for their particular use case. So in that case, we were actually developing an API plugin to create and list and destroy virtual networks on the SolidFire system, and then also to be able to create SolidFire volumes outside of the process of the normal SolidFire storage plugin that I had. They had a need for being able to create virtual networks and volumes, and then consume those sort of right next to CloudStack, but within the same ecosystem. So it made it very nice for their admins and their users to be able to go into the same GUI and do whatever kind of cloud. What? You're leaving, Giles? And that's recorded. So where was I? So yeah, so you can go into your CloudStack GUI you can do all of the kind of CloudStack stuff that you would need to do, make your service offerings, all of your network offerings, things like that. And then side by side, you could go in and create virtual networks on the SolidFire system, particular SolidFire volumes that you needed to consume, and do that all within one, I guess, pane of glass, so to speak. So that's a nice way to extend CloudStack's functionality without having to actually change any of the core logic within CloudStack. Another reason you might want to do this, even if you could go in and change CloudStack's core logic, which is fine, you're kind of tied to their software development lifecycle. So usually people want to consume particular validated releases of CloudStack. Of course, anybody can go and grab the code base and make use of it at any point along the way, but typically customers want some kind of a officially validated release, the 4.8 or 4.9 release. So if you don't want to necessarily be tied to that development lifecycle, and your functionality does kind of fit in such a way that it would work through an API plugin, you might want to develop it as an API plugin so that you don't have to be on the same release cycle as the CloudStack community. Maybe you can go ahead and rev your plugin more quickly or slowly. You don't have to be in lockstep with the rest of the community. So what's our particular approach here to kind of demonstrate how to make an API plugin is that I already have a collection of existing API plugins. We'll go ahead and copy one of those. We'll just take the root folder, copy, paste it, and we'll start by going in just making some modifications to some basic configuration files. Some of that stuff is admittedly not the most interesting part of the presentation, so I'll try to make my way through that pretty quickly, but that's kind of how we have to start, is by, well, in this case, by copying and pasting an existing project and then going in and making some tweaks to it to be specific to the project that we're developing. The other thing I kind of wanted to point out here is what we are developing here from an API standpoint is going to be indistinguishable from any of the other CloudStack commands that clients can invoke. So if they're accessing CloudStack through CloudMonkey or some other product that consumes CloudStack's API, your extended API commands will be part of that overall host of CloudStack commands. So there really isn't a difference from the client's point of view. And I think I mentioned it earlier, but you're not restricted to having just a single API plugin in your environment. I could make one for SolidFire purposes. I could make several for SolidFire purposes. Somebody else from a different company, either within storage or not within storage, could make their own. And we can all kind of live side by side within the same API. All right, so kind of getting to some of the basic stuff before we get into the, in my opinion, the more interesting part, the Java code. What I've done here is I've gone on the far left and I'm in the root directory for my CloudStack source code. I've gone down to the plugins directory, within that to the API directory, and then finally, we see a list of existing API plugins. Each one of those folders has its own Maven project in it and Java code. So what I've done here is I've actually just copied the SolidFire plugin, which is circled, and you just paste it back in and give it whatever name makes sense in your particular case. I just decided to use something creative like ABC123. So we're going to hear that quite a bit over the next 30 minutes. All right, so now that we've got our ABC123 directory, we can go in there, and there's a Pom XML file, so project object model file for Maven. It's just an XML file. If we just go into that, edit that, we can see there's a few pieces of interest that I've circled. The top one is just the name that we want to give to the artifact, the jar file. Here it's going to be cloud-plugin-api-solidfire when you first see it. So you'd probably want to go in and change that. Maybe at the end might be API-ABC123 or whatever your project is. You want to give it some name that makes sense for your particular project. And likewise, the name field below, that's just something kind of FYI. So I just have SolidFire API plugin. Maybe you just put in ABC123 API plugin, whatever makes sense there. That middle piece of information is just the version that I'm ideally compiling this plugin against. If you just did a copy and paste of my folder and you're planning on targeting that particular version, then chances are you won't actually need to change that piece of information in the middle. If you were taking the code that you had copied and moved it to a different branch maybe that has a different version of the code, this is just where you would go in to change that version number so that it matches the other projects within your Maven environment. The dependencies section at the way bottom, that may or may not apply to you. In my case, I actually have code in my API plugin that depends on code that's in my SolidFire storage plugin. So all I'm doing here is I'm adding a dependency so that Maven knows that this particular API plugin is dependent on this other block of code. You might have other things, maybe you have Google code that you reference or something else. This is just where that code goes. I've just circled it here just to kind of point it out that maybe you have nothing in there, maybe you have a whole bunch of dependencies. This is where they would go. All right, so now that we've changed that POM file, there's actually going to be a whole bunch of files if we just did a copy and paste that have the name SolidFire in them. So not very fun, but we'd have to go in, just search and replace. Change folders that have the name SolidFire to ABC123, change files to ABC123. Once you've done that, and now we're very close to getting past some of these tedious details, we can go into one of the files, module.properties. And that one there, if we actually just go into that file, we're just going to see another listing of SolidFire that needs to be changed. So name equals SolidFire, just change it, name equals ABC123. At that point, we've kind of done all of the really sort of tedious search and replace, and we're kind of well on our way to getting to some of the more fun stuff. Oh, but not quite yet. I forgot about this file. There is another file, a Spring-related file for the Spring framework. It is going to be called, if you did your search and replace, it would be called spring-abc123-context.xml. If you go into that one, at the bottom, you'll see a bunch of lines that have sort of the syntax bean, some text, and then the close tag bean. We're going to want to have at least 3 of them remaining in that file. If you look at the syntax, it's bean and then ID equals something. That ID is actually not used by CloudStack. It's something that you could use from within the Spring framework, but we don't actually make use of that in CloudStack at the time being. So I just changed that to make just some name that kind of makes sense. In this case, for the top one, it's just ABC123 util. The class is the one that's actually important, so the next field to the right. That should be the fully qualified name of a class that we will create. So right now, we don't actually have an ABC123 util or manager impl, but we'll get to those. And for right now, we're just going to reference them as if they really were there. And by the end of our presentation, they actually will be there. So really just these 3 lines, they're related to Spring's injection framework. So within your Java code, you can annotate things like @inject, and Spring will go through and look and see, okay, if there's only one instance of the ABC123 util class, then I can actually just go ahead and automatically set the property within your Java class so that it's very easy to kind of arrange for your dependencies from a Java environment. All right. Okay, I forgot about these ones too. There's just a couple little more config files that we got to change. This is not the fun part. If you go back to CloudStack's root folder, look at the plugins directory and the Pom XML file, there's going to be a modules section. If we just add an extra line into the modules section, it's just module the name of your module. So it's going to be API. Everybody's going to start with API / and then the name of your module. In this case, just ABC123. So this will allow us, when we do our compiles within Maven, it'll pick up on our new Maven module and go ahead and attempt to compile that as well. Now there is one more thing. When we run the CloudStack management server, that information is going to be stored off of CloudStack's root folder. There's a client directory with a Pom XML file in it. When we run the CloudStack management server, Maven's going to look at that Pom XML file and try to resolve dependencies. We want to make sure that we have this dependency section in that Pom XML file that's in that client directory. So when we run the CloudStack management server, Maven will go ahead and say, all right, do I have this dependency satisfied? If I do, great. Otherwise, go ahead and get that dependency. Now, I think at this point we've covered all of the configuration stuff, and hopefully if I hit enter here, I can actually get onto some Java stuff. Yes, great. Sometimes these machines, they'll have it like set up side by side so you can see the next slide. This does not. So, but excellent. We've gotten past all the configuration stuff. Now we can get into some of the more interesting Java code and some of the way we design API plugins to be modular within CloudStack, reusable, all of that good stuff. So here we see we've got a client on the top issuing this URL to make something happen within the CloudStack management server. So we just see HTTP, we've got an IP address, port number, client API. The method that we have here, delete ABC123 virtual network, that is a CloudStack API command that we are going to make sure exists by virtue of our new API plugin. So it doesn't exist in a standard CloudStack environment. We're going to make sure that we write our API plugin to support that command. And, well, it'll support a host of other ones. But for the most part, we're going to look at just a couple of them. Delete virtual networks, list virtual networks. And so you can see that it looks just like any other command coming into CloudStack would look. It's just serviced by a pluggable piece of the code base. And then as an example to the far right, we can see that not only do we want to invoke that delete method, but we want to pass information into it. Just like if you wanted to delete a volume or something like that, you would want to pass in the volume ID. So here we're saying, call this API command, pass in this piece of information. If we had additional pieces of information that the command required, you would just see additional @ symbols, the key equals value for the next property and its value. But it is no different than any other API command within CloudStack. That URL is going to be serviced within CloudStack, and CloudStack is going to figure out which API object can handle that particular command. That's going to go to our top layer, as you'd expect, the API layer. The job there is to basically take those parameters that came in for that particular command, figure out which business object within the system can get the work done, take the result from that business object, and then package it back up in an API object that gets sent back to the whatever called it. That could be CloudMonkey or the GUI or whatever is calling us. So the API layer is going to know about that middle layer, the service layer. That's really our business layer. So in Java sense, your API code could have an import that says something about importing something from the service layer. The service layer, though, is not going to know about anything above it. It just knows how to perform certain business tasks. It happens to be, in this case, that the business tasks are going to be invoked from the API, but it doesn't have to be exclusively that way. It could be that this business logic sometimes gets called from the API. Maybe it's called from some other subsection of CloudStack. So the service layer is just there to execute business logic. And it doesn't really know or care who's calling it, if it's being directly invoked from the API layer or some other subsection of CloudStack. So the service layer does not know about the API layer. The service layer does know about the layer directly below it. In this case, my data access layer is going to a database, but maybe it's doing some kind of using some other kind of data storage technology. The service layer, either way, knows how to interact with the data access layer. And likewise, the data access layer doesn't know who's using it. So kind of at a high level, API knows about the service does not know about the API. Service knows about the data access does not know about the service. If you looked at the API, it does not know about data access. Every layer only knows about the layer below it, nothing else. All right. So these are the main classes and interfaces that are required to actually accomplish building an API plugin in CloudStack. And I've got this throughout the presentation kind of broken up into the API layer and the service layer. If we start on the left with the API layer, and I don't know if you can actually see it so well on the screen here, but the red outlined boxes, those are classes. The black ones are interfaces. The black ones with the dashed lines, those are optional interfaces. So we've got a couple required classes, a couple required interfaces, and some optional interfaces. If we look at the way bottom of the API layer, we've got API ABC123 service impl. And on the right for it, it extends adapter base. That's just a requirement for these kinds of API plugins in CloudStack. They just extend adapter base. That guy provides a bunch of basic functionality so that typically your API plugin doesn't really have to have a whole lot of code in it. To the left, we can see that, and this is just kind of a common Java paradigm. My class that ends with impl, it implements an interface that looks exactly the same, but it doesn't have the impl part. So it's just an interface API ABC123 service. Now it's that interface that actually extends a couple other interfaces. On the far left, pluggable service is a required interface. So API ABC123 service has to extend that interface. And that's really what makes you a pluggable service API object. So this is a requirement so that CloudStack can discover you as an API plugin. The API checker, which I've got in dashed lines, that one there it exists in case you have certain requirements as to who can actually access your API commands. You might have a delete method, and maybe the default, what we'll see later, the static role-based API checker, maybe it doesn't do enough to actually control who has access to that particular method, and you have to do some special things on top of it. This will allow you to do that. And we'll see later, for example, maybe you don't like the name username Bob. Anybody who's got the username Bob, we're just going to deny that guy. I don't care what account you're from, I just don't like you. So you can do things like that. As it turned out, in my experience, I started down the route of using an API checker and then realized that there really wasn't anything that I needed above and beyond what the static role-based checker was doing for me. So I ended up pulling out my implementation of API checker. But it is there, and we will go through a little brief code segment on how to actually implement it. Then on the far right side, you have the service layer. So this is our business layer. Again, we got the API layer at the top. We've got our service layer below it. This is what's actually going to be invoked by the API object to get some real work done in CloudStack. Similarly, we see it's ABC123 manager impl. It extends or implements an interface, ABC123 manager. That ABC123 manager interface, you're going to see that's what's going to have all of the required business methods that need to be implemented. So in my case, it happened to be things like create a virtual network, delete one, list one, create a volume, delete one, list one, create a reference to a SolidFire cluster, remove that reference, all of those kind of things. And that particular interface can, although it doesn't have to, it can extend the configurable interface. And in my case, that was actually useful. That is what allows you to have things like global settings associated with your particular plugin. In my case, they weren't global settings. They were account level settings. For every account, I wanted to have certain settings that you could set the min, max, and burst IOPS and a certain number of maximum bytes and things like that. That's what allows you to actually have that already basically leverage CloudStack's existing global configurations environment to be able to add new global settings within your particular environment if your plugin actually needs that kind of stuff. If you don't need that kind of stuff, you wouldn't bother to implement that configurable interface. So let's go ahead and take a look at the service layer first. So that's the one on the far right. If we were looking at our original diagram, API layers on the top, service layers in the middle. So this is the business logic. And in my case, I had an interface that I called ABC123 Manager. And like I mentioned a second ago, I had that extend the configurable interface because that is actually going to be useful for me. The configurable interface, just to make it kind of simple to see what that looks like, it doesn't actually have a lot of requirements. There's just two methods. One is getConfig component name. Now this is really only useful if you have, let's say you have multiple API plugins running in your CloudStack environment, and maybe I have a name clash with somebody else's plugin. What you'd actually see there, if you looked in the log file, is it'll tell you that there's this kind of situation exists, and it'll print out the name of the API plugin, or in this case, the business object that had an issue. So what I did was I just took the when I actually implemented configurable, which was implemented in my ABC123 manager impl class, I just took ABC123 manager impl.class to get an instance of the class that describes that class, and then I just got its simple name. Maybe you want to get the fully qualified name, whatever can allow you to debug that if in fact you ever do have a name conflict with somebody else's plugin. The stuff that was more interesting is that getConfig keys method below it, and we'll see that implemented on the next slide. So here, we've got a public class. This is my business object, ABC123 Manager impl. Again, it implements the interface, ABC123 Manager. At the bottom, we can see that I implement that getConfig keys method. And it's pretty simple in my example here. You just return a new config key of unknown array. And then in line, you can kind of just bracket it and stick in the name of the variable names of your config objects. If you look, I just have one in this example. In my real plugin, I had actually, I believe, 4. But just to kind of keep it simple here for the projector, I just have the 1. If we look at that one, we can see it's a config key of some type. So this is a config key of long in my case. This is something that's the actual admin could go in on an account by account basis and say, all right, for this account, I want to give this guy X number of bytes from the SolidFire SAN. I want to give this guy Y number of bytes. So some kind of a number. And we can see if we look at some of these fields, it's a long. It's actually the name for the admin when he went in and tried to fill these values in. The property name is just abc.123.total.capacity. So that's where I specify that. And so you could just tell the root admin, go in and find the abc123.total.capacity field, fill it in for the accounts that you want to give access to this plugin so they have some number of bytes, and then they'll have the ability to go ahead and create volumes without immediately running out of space. If you look below that, the default value is actually 0, which effectively means that even though end users can see through the GUI plugin, they can see this functionality, unless the account they're a part of actually has been given some number of bytes and some performance from the SAN, they can't actually use it yet. So this is the way I control who has access to really use my plugin, and it's just done through an account setting. So let's move on to the next one here. All right, so we're still in the service layer, so our business objects, we've done the configurable part. Now is the part where we actually need to go in and specify some business functionality that we have to later implement. And this is where I mentioned, these are all of the list this, delete that, create that. So here I just have just a simple example, just two methods, list virtual networks and delete virtual network. And we can see here, I just sort of followed regular CloudStack convention. My list method takes in a capital long, L long, so a wrapper long. So if you actually pass in null, it will list everything that you have access to see. If you pass in a number, it'll go ahead and just list that particular virtual network. And that's just kind of a convention that we've used within the CloudStack community. Maybe at some point in the future when we actually support Java 8, we might be able to introduce the optional class and make that look a little bit more sophisticated. But for now, we typically just say if the value is sort of optional, we use a wrapper integer long, and null means just everything. The other one below it, though, if you're deleting something, you would expect that they actually have to pass in a particular ID for that virtual network. So I made that one just a primitive long. And so just to kind of point that out, that's sort of convention in CloudStack, and that up until at least Java 8, that's just sort of a general purpose Java convention. All right, so how might we actually implement that? So we've got our interface, ABC123 manager. Now we want to go ahead and implement those methods. I'm in the ABC123 manager impl class, which extends that interface. I won't go through all of this code. What we're basically doing here is we're taking in this case it's a delete method, we're taking in that ID and we're turning around and saying, well, remember the business layer sits on top of the data access layer. It knows about that. So what I'm doing is I'm performing some checks. If everything looks good, I'll go ahead and talk to a data layer object and delete that object from the database. Once that's done, I'm going to go ahead and return a pointer to an object that basically has the contents of the information that I deleted from the database. And that's just kind of the way I implemented it here. Maybe in some other cases you might return a Boolean and just say true, it was successful, or false, it wasn't. In my case, it'll throw an exception if it fails. If it doesn't fail, it'll return a pointer to an object that represents the data that was just deleted. The one thing I did want to point out there is if you see that class, that interface rather, that I circled, it is actually an interface type. So even though this data existed in our MySQL database and it is represented by a VO object, a value object, and that VO object would be ABC123 virtual network VO. I don't want to return that type because that is going to be exposing to the API layer my implementation details. I just want to return a pointer to an object that implements a particular interface. If at some point in the future we decide we want to move away from MySQL, maybe don't even use a relational database, use some other kind of persistent storage, we can have a different implementation class implement that ABC123 virtual network interface. And this layer here, as far as its interface is concerned, does not need to change, just its implementation. It would go to a different persistent storage device and do whatever it has to do to get rid of that object, but it would still return a pointer to an object that implements the same interface. So that way you don't really have to expose to whoever's calling this business logic any of the lower level details concerning how the object is actually stored, in this case kind of physically in a relational database. So that was kind of the main thing to point out there. Now, if we shift over, that was kind of all of our business logic, our service layer. Now we're going to go up a level to our API layer and see how that works. In this case, I have just my one interface, API ABC123 service. And way back from the other diagram, if we recall, that particular interface extended two other interfaces. The Pluggable service interface, which is really what makes this an API plugin, and then the optional interface, API checker. And we'll see again, I'll talk about it. API checker is optional for a good reason, and in fact, I decided not to actually implement it in my final API plugin that I passed on to our customer. So just to kind of give you a feel for what is required of those two interfaces, Pluggable Service and API Checker, in the middle section there, we see the Pluggable Service interface. It just has a getCommands method, returns a list of class of unknown. We'll see how that gets implemented in just a second. And then the bottom section is the API Checker, and just has one method, check access, passes in a user and the API command that he would like access to, and then you can actually accept or deny access to that particular functionality. So let's first take a look at the Pluggable Service method getCommands. What this is doing is your API plugin is going to be asked by CloudStack when it discovers the API plugin, what commands do you support? It's going to call getCommands to find this out. All you have to do is make, in this case, I made an array list of type class of unknown, and I just added all of my command types to it. So in this case, you just see CMD list. That's my pointer to my array list. I just called add a couple times. In reality, my API plugin does have a lot more functionality, so there really is more like a dozen and a half of these add methods. Just for the sake of simplicity, I pulled out most all of that stuff and just left in two of them. Here I'm adding, and it just says here, list ABC123 virtual network command. So that's my class name, .class. So what CloudStack wants you to add to this array is an instance of the class that describes your type. And the way you do that is just by saying add the name of your class, .class. So we haven't actually made these command classes yet. We'll get to that in a second. But each one of these command classes represents its own API command, just like what it looks like. List ABC123 virtual network command. That is going to service whenever somebody says list ABC123 virtual networks, it's going to come to this command object, and it's going to go ahead and do its thing, talk to the business layer to get those virtual networks, package them up into a form that is going to look good for the API, and pass it back to the client. So this here, this will have all of your commands, and we'll get to those in a little bit. Moving on here. Before we do the API checker stuff and kind of comment on how optional it is, the reason it's so optional is because we already have, at the way bottom, you can see it's called static role-based API checker. No, static role-based API access checker. There's an API checker that already exists within CloudStack, and it actually enforces certain rules based on a file called, let's see here, commands.properties. So that's listed at the very top. Commands.properties, not a super exciting file. It's just a bunch of key value pairs. It's the name of an API command equals the permission level. 1, for example, means a root admin can do this, nobody else. 15 would be everybody. So what are valid are 1, 2, 4, 8, and just add them all up. That gives you 15. That means everybody can do it. And that's a pretty common thing in the Linux world. So that static role-based API checker, it's going to read this file when the CloudStack management server starts up, and it's going to see all of these API commands. It's going to know what account your user has to belong to be able to call certain functionality, and most all of the time that is sufficient. So what I found was I could list all dozen and a half of my commands, and it was all based on the account. If you belong to this account, you either had access to that command or you did not. And so I didn't really have to do anything fancy. We'll see in a bit that you can do things a little bit fancier if you want to. If I wanted to say, for list ABC123 virtual networks, right here I'm saying everybody can do it. If I wanted to, I could confine that later by having my class implement API checker. And when it gets passed in list ABC123 virtual networks, it could take a look at that specific user. And kind of like I mentioned before, if it didn't like the name for some reason, doesn't like Bob's, it could just say, no, you don't get access. I don't care what the other API checker said. All of the API checkers basically have to say yes. If anybody says no, you don't get access for that particular command. So you do have really fine-grained control over this. It's just a matter of whether or not you actually need to take advantage of that. And in my particular case, I didn't really need to. But it is there. Oh, and this is actually a little bit of code. So when I had implemented API checker, I had something like this. There's a check access method. In this case, I was just checking, hey, if you're a root admin, sure, I'll give you access to that. And then I had to check the name here. I didn't really care what you were asking permission for. If you're a root admin, you get permission. If you're not a root admin, then maybe if it's list ABC123 virtual networks, sure, I'll give you permission to view that. Anybody else, I was throwing an exception. And the funny part here is I looked at the code later. Boolean as the return type, that's great, but the code that calls it doesn't actually look at the return value. So it'll invoke check access, and if you do not throw an exception, permission denied exception, you're in. So originally, I implemented this as just return true, return false. Doesn't work that way, apparently. I mean, it might have been like somebody originally thought that it should work that way, but it doesn't work that way. You got to throw an exception if you don't want them to actually have access to that particular command. And that was just sort of, there wasn't any documentation that I saw on it. I just, as I was testing things out, all of a sudden, I was like, I have access to it regardless. What's going on? And then I looked at the code, and it's like, yeah, it doesn't care about the return value. So, pro tip. So, all right, so we talked about those command classes. Those are the ABC123 virtual networks, or list ABC123 virtual networks command dot class that we wanted to add to our array list to tell the CloudStack management server that we actually support a command by that name. Now, this is how we actually implement that. And we can see here, so here's the name. Delete ABC123 virtual network command. They all kind of follow that same pattern. It starts with create or list or delete or something like that. It ends with CMD. We have other command classes in the CloudStack codebase. They actually end with the word command. Those, I do not believe, are ever actually these API commands. I think they're other commands, like if you're sending a command to a hypervisor, you might create an instance of a command class that ends with the full word command. Those are typically when you're talking to hypervisors. This CMD kind of abbreviated word, those are typically associated with API commands. I mean, to be really on the safe side, you can look and see what it extends. In this case, it extends a class called base command. If you were listing virtual networks here, the list ones typically extend one called list command. I noticed we are not entirely consistent throughout the code base that deletes extend base command, lists extend list command. So what I recommend is you, if you're kind of not so sure if you're extending the right class, just take a sample of a bunch of delete commands and see what are they typically extending. In my case, when I did my research, delete, it was safe to extend base command. When I did list, it was safe to extend base command. It's possible that you can get away with extending a different class, and if your particular use case doesn't really warrant it, you might not need the functionality that would have been in the other class. But typically deletes extend base command, list extends list command. Just kind of look at existing precedent in the code base, and that'll probably give you a good idea as to which of these command classes you should extend. If we look at the top, it's got an annotation at API command. So we want to put this in. The name property within that, in this case, delete ABC123 virtual network. That is what the client is actually going to be sending when they have their method equal within their URL. That is what they are going to be putting as method equals delete ABC123 virtual network. The other things like description, that's useful for documentation purposes, things like that. If we actually look at the implementation of this class, we're going to see things like all of these command classes tend to have a property named s_name. This is information that's actually going to be used by the client to track down the piece of information that you're passing back. So it might be a JavaScript front end or whatever. They're going to start with delete ABC123 virtual network response. It's super verbose, I know, but this is just kind of the pattern that these commands tend to follow. They start with the word list or delete or create. They have the name of your command, and then they end with the word response. So when I did mine, I just took what was there in an existing template, and I just changed it. I just left the delete, left the response, changed the stuff in the middle. We'll see later when that's actually invoked, but that's going to be something useful to the client. I only have one parameter in this particular case. It's the ID of the virtual network you'd like to delete. Again, your parameter is going to be annotated, in this case with an annotation called parameter. Just has some basic properties here. The one that's really of interest is the type. In this case, it's a UUID. So I tried this. Some of the command classes have this wrong. They actually put in, I think it's a long. If you put in a long, then the end user actually has to pass in the ID, not the UUID. So in the CloudStack database, we have IDs and UUIDs. In the CloudStack GUI, what we call an ID is actually what we call a UUID in the CloudStack database. If you say here that the type is a long, that's going to mean that the end user has to pass in the actual ID from the database, which most of them don't have access to that. It's not typically returned through the API. So what you want, in this case, since this really is a UUID, say that it's of command type.uuid, that actually gives people the flexibility to either pass in the UUID, or if you're a developer and you know the ID in the table and you don't want to like copy paste the UUID, I mean, I might just go real quick and look. I might have it in a virtual machine and just maybe my copy paste isn't working across. So I can just go ahead and look and see, all right, that's ID 3. I can stick in 3 for the UUID or the ID, and you can submit that command. CloudStack is smart enough to realize that if the parameter type is of UUID and you pass in a long, it doesn't match the format of a UUID, it will go and look that up in the database for you and well, actually, it'll leave it as a long in this case. If you pass in the UUID, it does the reverse. It looks it up in the database for you, and it puts in the long value. So anyways, it's just much more flexible if you specify your ID as a type UUID. And I noticed some of the commands don't do that, so they're kind of limiting how people can invoke that functionality. So, try to avoid that. I know once you get the stuff into the field and people have been using it, it can be hard to change. So that's just one thing to maybe take a look at beforehand. At the very bottom, I'm actually using the Spring framework to inject a couple objects into this command object. So way back when we were in that one file that had the bean XML and it specified a fully qualified name of a class, that is how you tell the Spring framework to make an instance of that class. And that, in conjunction with these @inject annotations, is how Spring will take up that pointer it created to that object and stick that pointer into your your class, or your object, in this case my virtual network command object, and make it very easy for you to resolve dependencies. So that's a very easy way to always, a lot of my command classes, they have, when you make instances of them, they're all going to want pointers to the business layer or to this utility object that I have. So this makes it very easy to get those pointers without having to add a whole bunch of extra code. All right, so we saw just a second ago, and I kind of glossed over it. We don't need to spend much time on this, but that s_name, the only time it's really used, and I'll go back here, is in the implementation of the get command name. So when you make your command class, it extends, let's say, base command. One of the methods you need to override is get command name, and then below that, get entity owner ID. So your command name is typically just that variable that we called s_name. And that, again, that's going to be used on the front end to reference the data that comes back from the API command so that they can retrieve the particular piece of information that they're interested in. The entity owner ID, now this is actually an overly simplistic implementation. Typically, you would actually go and, like if you wanted to delete a virtual network and you are of account X, we might want to go and actually take a look, have the API object here, talk to the business object and say, hey, what account is this virtual network associated with? And if you're okay with the account coming in, deleting something that's owned by that other account, maybe they're the exact same account, then you can just pass back the appropriate account information. Otherwise, you can throw exceptions and things like that. This is just a way for you to circumvent your actual functionality, even needing to be invoked if it's being invoked by somebody from an account that doesn't have permission. So I can say, delete this guy's virtual network. CloudStack can look and ask the API plugin, who owns this? If you, who are asking me to delete this, don't own it, I'm just going to return an error. I'm not going to go further and tell this guy to go ahead and do anything. It's also nice for listing the APIs. You can say like, hey, list all of the APIs that I have access to. If you just can never delete virtual networks, okay, well then you won't see that in your list of available APIs. So that's just one of the ways to kind of circumvent invoking code on your API plugin, and then your API plugin discovering that, hey, this guy doesn't really have permission, I'm going to need to throw an exception. This just kind of circumvents that whole thing.
Where did you get the underscore account ID from?
Yeah, see, that's the thing. So originally, when I was that was in a very early step of development, and I was taking the data that came in from the command, and just at the time I was just saying whatever account came in, just pass it back and say, sure, you have permission to do this.
Where did you get the account from?
Oh, whenever you invoke a command, it's going to be done either through your API keys and all that kind of stuff. It's going to know what account you belong to.
That's already injected?
Yes, you don't even have to, you don't even have to.
Based on your API key and secret key, it knows who you are.
And it's available to the code.
Exactly what Will was saying there. It's going to know based on your API key and all that who you are. It's available to the code so you can check on that kind of stuff. And when I was in a very early cycle, I just took that value and just said, sure, you have access to do whatever you want. And then later I went and I made it more of a detailed implementation. I just didn't catch that from the slide deck later. So assuming you do have permission, the API doesn't have any good reason to deny you access to that functionality, that's when it invokes this execute method on your command class. Typically what your execute method does, it's not usually very long. It just takes the parameters that were passed in, and it might do some validation on them if it needs to. A lot of times that's already done by CloudStack's infrastructure. But if there's some additional validation you need to do, you can do that here. Then you can pass into your business object, invoke whatever functionality it has that supports the needs of this particular API command. So here we're calling the delete virtual network API command. In turn, our API object is going to look at that underscore API ABC123 manager object, which we injected. And it's going to say, delete virtual network, here's the ID. That business object is going to do whatever it has to do. Like we saw in the previous slides, it actually does some validation, and then it goes to the database and actually deletes the data, and then takes the old data, packages it up in an object, and sends it back. So we can see here what comes back to me is an object that implements the interface ABC123 virtual network. So I don't have any information living here in the API layer. I don't have any information as to where that data resided, if it was in a relational database or, I don't know, object store or something. All I know is I told you to delete it by passing me back a pointer to this data and not throwing an exception. You deleted it, that's great. I'm going to take this information that you sent back to me, and I'm going to package it up in such a way that it's now in a state where I can send it back to the API. To the client that invoked the API. Now, why is this particular business object not already in a good state? It's in a good state for internal use, but our business objects look a lot like they belong in a relational database. They have the ID of maybe the cluster they belong to. They have the ID of that. So if you really want that other information, you'd have to go and query some other table to get, maybe if I have my virtual network, I want to know, well, which SolidFire cluster does it belong to? Well, here we might have the ID, but we don't have the name. We don't have some of the other characteristics. So what we're going to do here, before we send it back to the API, to the client, we're going to kind of follow all of those links. If I'm deleting a virtual network, maybe I want to tell you, okay, it belonged to this SolidFire cluster. It had that SolidFire cluster not only had this ID, but it had this name. It maybe had these other characteristics. So that way, when you get that information in the client, you have everything you need. You can just take that information and display it as you need to in your client, whether that's CloudMonkey, the CLI, or the GUI. Otherwise, if we just passed you back the business object, okay, it'd be nice it had the name of the virtual network and things like that, but it might also have the ID of the SolidFire cluster. Okay, well, maybe the GUI wanted to display the name of the SolidFire cluster, not just the ID. Now the GUI would have to go and make another API call and say, hey, CloudStack, can you give me the information on this SolidFire cluster? I want to know its name. I want to know how much capacity it has, all that kind of stuff. So what we're doing here, once we get the data back from the business layer, is we're going and filling in all of those details that we think a client might be interested in, and then just sending that information back to the client. It just makes it's going to increase the amount of data going back, but ideally it's for a good cause. The client is going to actually take that information. I know CloudMonkey just takes it and displays everything to the end user. So in the case of CloudMonkey, it would just display all of that stuff. If the person who deleted the virtual network wanted to know what the name of the SolidFire cluster was, he would see that. Otherwise, if he just saw the ID, he'd have to go and issue another CloudMonkey command to get the name of the SolidFire cluster based on the ID. So it's just, oh, am I talking, is it already late? Oh man, okay. We are almost done.
Quick one, the underscore API manager and underscore ID are also available in the same way?
API ABC 123 manager, that was my own business object that, I'll go back here, I'll show you where I got that from. If you look, yeah, right here. So, and this is using the Spring injection framework. So way back in the beginning, we had a config file when we were kind of doing the less interesting stuff. Okay, cool.
An ID?
I'm sorry, what was that?
The ID underscore ID?
Oh, the ID. So that, if you look on top, it's annotated at parameter. So the actual CloudStack infrastructure is going to expect that. And we said on the far right, one of the properties says required true. So if you issue that URL that says delete virtual network and you do not pass in an ID, CloudStack already knows that it should expect a parameter called ID, which is of type UUID. And if it doesn't see it, it'll just send you back an error without even doing anything really, a lot of interaction with my plugin. Cool. All right, so this is almost done. This is just, so we were talking about fully expanding those objects to have all the extra information. That's just what this class does. So typically what you do is you start the name with API, then you give it whatever makes sense in your case, and then you end with response. And it extends base response. What I do here is I have, everything's got @serialized name, and then some name. That's what the client is going to see. So they're going to see a parameter come back, ID equals something. They're going to see UUID equals something else. This is how I create a Java object, populate it with all the information I need, and then when I give that to CloudStack, CloudStack knows, because it's annotated this way, that it knows to send back to the client. Let's call underscore ID, we're just going to call that ID when we send it back to the client. Underscore UUID, we're just going to call that UUID. And so from the client's perspective, it'll just see the things that are called serialized name and then equal some value, whether it's a long or a string. Okay, and then we can skip through most of this. This is simply taking in your business object and then taking the data that you want from that business object, putting it in your response object. If you need to follow links, like I have the pool ID, but I don't have the name, but I want to send back the name. Okay, I'm going to go and query for the name of that pool, put it in my response object. Maybe you're not a root admin, so right here, maybe I'm not going to give you some information because you're not a root admin. So I have control over what you get to see when I send it back. Okay, I'll just kind of call it good on that. And that's it. The last slide here is simply to deploy this. You've compiled, you've created a new jar file, shut down the CloudStack management server. This is the second line is a path on Ubuntu, but there's something similar on CentOS and whatever OS you're using. Put it in your classes directory. Make sure that your what is it called, the commands.properties file, that's the one that lists command equals whoever has access to it, whichever accounts. Make sure that's up to date, and then just restart your CloudStack management server and you can start issuing commands. So I think that actually concludes everything. Thanks for hanging out with me, and anybody got any questions? All right. Oh, you got a question?
So what are the restrictions, are there any restriction of what an API plugin code can access?
No. So the question, since this is being recorded, is are there any restrictions on what the API code can access? The answer is no. And yeah, that is a bit troubling sometimes, because if any plugin in CloudStack, doesn't matter if it's a storage plugin, API plugin, network plugin, they do not run in a sandbox of sorts. They have access to anything. If they accidentally corrupt something in the database, maybe has nothing to do with them, there's always a risk of that when you don't run in a sandbox like that. What was that?
It does play a little sound though. It goes wah, wah, wah.
I don't know about that, but we've had several discussions over the years about that. Unfortunately, CloudStack does not run plugins in sandboxes, so there is always that risk. Mm-hmm. Yeah. Okay, I guess we're out of time here. If anybody has questions, just come get me after. Thanks a lot.